So we finished descriptor pre-processing, and then we're going into feature selection. So we've done so far, we drop NaN, NaN values from the dataset, and now we're going into feature selection. You can simply search this Scikit-learn feature selection, then you'll find information about it. And if you click this website, official website of Scikit-learn, you can learn more details about feature selection. So there are many different algorithms for feature selection. And what it does is that we have structure like this, and it has many different values. We have actually too many. In our case, I guess training says around 60, and let's say this is around 600. We don't need this much number of features to train the model on 60 molecules. There is a known rule. It's a 5-to-1 ratio rule, which means if we want to train one weight, we need at least 5 data points, which means 5 molecules. So if we have 60 molecules in training set, maximum feature should be 12. So we need to find which 12 of descriptors and which combination can make a best prediction result. So this is what feature selection does. Feature selection helps to find the best combination and best set of descriptors. So there are many different algorithms to find it. But basically what it does is it trains the model with all different combination and suggests the best combination. So if it is possible that we can try all possible combinations, then we can just do that. But if but we have limited time and limited computation resource, so this feature selection algorithm helps us to do the task with the reasonable computation demand and within a reasonable time to find the best set of descriptors. And in this course, I'm gonna use the simplest one, which is a forward selection. Here you may see forward here, sequential feature selection. Here there's a forward and backward. So forward means among the descriptors. Here's an example of descriptors. Forward selection selects forward, so it selects first descriptor, which is the best descriptor when only one descriptor is selected. So it selects first one, and then it selects the next one. Given that the first descriptor is already selected, which descriptor should come next to make the best prediction accuracy? So it finds a best combination with two descriptors, and then it selects third one, fourth one, up to the number I set to select. So it's sequentially select first, second, third, fourth. This is a forward selection. If it's a backward, it's removing descriptors one at a time. So if I have a 600, then it's removing one. So it's sequentially going backward by removing the worst descriptors one at a time. So this is backward, and this is the backward selection. This is forward selection. So we are going to use this one, and you see this is the number of features I want to select. So this sequential feature selection helps us to find the best features based on the given number of descriptors. So what I want to do is let's examine which number of descriptor is the best descriptor. So I'm going to use this and develop the model like with 3, 4, 5, 6, and so forth. This is the number of descriptors, and this is the performance, which will be score of the model. And then it will, and I'm gonna draw this line first and second. So I'm gonna test it. I'm gonna make a plot with a test set and training set. If normally it doesn't increase because training set will continually increase, but test set will increase at some point, but it will decrease and then increase again. Something like this can happen. So based on this test, I can suggest that maybe this is the best, or I may select this as the best. If I think this improvement is not really important, then I may select here, because lower number of descriptors lead to lower possibility of overfitting. So the main purpose of this part is drawing this learning curve. Learning curve.